Okay, in this video, we're going to be taking a look at the Unit 3 review. And the Unit 3 exam will cover quadratic functions, polynomial functions, and long division. And I wanted to start out by giving you some information about the actual test itself. On the test, there are 35 multiple choice questions, and they are 4 points each, which means you have the 150 points total. There are 18 questions related to the quadratic functions. For polynomial functions, there's a total of 12 questions. You have 4 that ask about the end behavior. There are 2 that ask about the number of zeros. There are 4 that ask about the estimation of the zeros. And there are 3 about the number of zeros. I wrote it down. Couldn't read my handwriting. Okay, and 1 about the domain of a polynomial function. And there are 5 long division problems. Okay, so that kind of gives you an idea. And they're in that order. Quadratic functions are first, then polynomial functions, and then long division. So you may want to organize your notes in that order. That's the order in which we learned it. So hopefully you'll have those pulled together. So we're going to take a look at the quadratic functions, and you'll have 120 minutes or 2 hours to take the test. You can use your notes. You can go back and look at the Zoom videos, whatever resources you have in D2L. Again, other than some other person, you can have those resources. All right, so let's begin with the review. And the first 2 groupings of questions, I believe, deal with quadratic functions. And the first question says, use the following function to answer questions 1 through 7. And you're given a function, f of x equals 2x squared minus 4x plus 3. And again, I hope that you recognize that that is a quadratic because it has a squared term. And then the first question 1 says, what is the domain of the given function? Well, the fact that I have a quadratic function, okay, and I have a quadratic function because I have a high exponent of 2. And if you go back and look in your notes, I told you from the beginning with quadratic functions, the domain is always negative infinity to positive infinity. There are no restrictions because if you look at this polynomial function, it does not involve fractions nor does it involve radicals. Therefore, our domain is negative infinity to positive infinity for quadratic functions every time, all the time. Then question 2 says, what is the direction of the opening of the given function? Remember, to decide the opening of the function, we look at a, and a is the number in front of the squared term. So in this case, a is a positive 2. Since it's positive, that implies that there's no reflection on the x-axis. Therefore, my parabola opens up. And I have used that terminology on the multiple choice part of the test. It opens up or opens down. I didn't use the funky notation that WebAssign used. So visually, this quadratic is going to be turned up so that it looks like a U shape. Question 3 asks me to find the y-intercept. To find the y-intercept of any function, linear, quadratic, polynomial, whatever. To find the y-intercept, we let x equal 0 and we solve for y. So for this problem, I would have f at 0 equals 2 times 0 squared minus 4 times 0 plus 3. You can work it out. 2 times 0, 0 squared is 0, minus 4 times 0 is 0, 2 times 0 is 0, minus 0, plus 3. So you end up with a value of 3. You are typically asked to write your y-intercept as an ordered pair. So my y-intercept written as an ordered pair would be an x value of 0 and a y value of 3. So my y-intercept is 0, 3. Fourth question asks you to find the vertex of the parabola. Okay, so now we're looking for the vertex. The easiest way to find the vertex of the quadratic function is to use the vertex formula. Typically, the vertex is in the form h, comma, k. The h corresponds to the x coordinate, which is found by doing the negative or the opposite of b over 2a. Then to find k, which is the y coordinate, we substitute x back into the original problem. And remember that your a is the number in front of the squared term, b is the number in front of the x, and c is the constant. So we would basically plug and chug into that particular formula. So I would have the opposite of negative 4 divided by 2 times 2. The opposite of negative 4 would be positive 4. 2 times 2 is 4. 4 divided by 4 is 1. So the x coordinate or the h value of the vertex is 1. So then I'm going to substitute 1 back into the original function. So I would have 2 times 1 squared minus 4 times 1 plus 3. And then I'm going to do the calculations. Now you can, if you'd like, pull out your calculator and do those calculations. I can pull my calculator up and show you how to do that. All right, so we would have 2 parentheses 1 close parentheses squared. Make sure I get it right. Minus 4 parentheses 1 close parentheses plus 3 and enter. And I get a value of positive 1. So when you do these calculations, you're going to get a value of positive 1. So my vertex written as an ordered pair, h comma k, would be 1, 1. So this is my vertex. We usually label it with a V. Then you're asked in question 5, what are the zeros of the given function? I'm going to write the function down again so I can still see it. It is 2x squared minus 4x plus 3. Now, I've reminded you several times recently, and I'll remind you here again so that you don't forget for the test, that the word zeros has several synonyms, and it can be flip-flopped at any point. So you have the word zeros that also implies not y-intercept, x-intercept. Let me get it right. Okay. X intercepts or intercept. It's also called solutions, or sometimes you even see the word factors. And we've also talked about that the methods for finding those zeros are either to factor, if that's possible, or to use the quadratic formula. And I do realize that the majority of you are most likely using the quadratic formula. So that is the method that I'm going to use, and I'm going to write the formula down for you so you'll have it hopefully handy when you're taking the test. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, again, when you're thinking about A, B, and C, remember A is the number in front of the square term, B is the number in front of the x, and C is the constant. And we begin the process by plugging and chugging. Okay, so we would have the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times 3 all over 2 times 2, which would give me 4 plus or minus the square root. Negative 4 squared is 16, minus 4 times 2 is 8, times 3 is minus 24, all over 4, which is 4 plus or minus the square root of negative 8 over 4. So I would have 4 plus or minus 2i square root 2 over 4. Now let me back up for a minute to show you where that came from, because some of you are probably freaking out. Negative 8, you'd have the negative 1, which automatically makes the I, times 4 times 2. 4 is a perfect square, hence the 2 that's outside, and then the other 2 remains in the radical. If I separate this out, I'd have 4 over 4 plus or minus 2i square root 2 over 4, which then simplifies to 1 whole plus or minus 2 goes into 4 2 times, so it becomes 1i square root 2 over 2. Guys, this is the answer that you would look for on the multiple choice, because in the instructions, and I know this because I wrote the instructions, it says to write it in standard form and to give the exact values. So you would leave it written with the radicals and break it apart so that you have the real number part and then, in this case, the imaginary part. Okay, so those are the numbers you would look for. So visually, when you look at, or if you were to look at the graph of this quadratic function, and we'll do that in just a minute so I can show it to you, you're going to see that there are not any x-intercepts that you can see. So if you're really looking for real zeros, then it's possible in terms of real zeros, and let me see if I can make a little note off here to the side somewhere. For real zeros, okay, they do not exist. You don't have any zeros that you can physically see on the graph, because these that we found are imaginary. Okay, so be careful about how the question is worded. Is it asking you for real zeros, or is it asking you for all the zeros. Okay, still looking at that same question, question 6 says, what is the range of the given function? So I need to go back up here just a minute because I need my vertex. So I want to think about this, and I'm going to kind of rough sketch here. I know that my parabola is going to open upward and that my vertex is at 1, 1. So that's actually my low point. So the first place I'm going to see this on the grid is when I hit a y value of positive 1. So my range runs from positive 1 through positive infinity. And again, I'll show that to you on a graph. So I'm going out to my graphing calculator. Y equals, I'm going to clear out the one that's in there. We're going to type 2x squared minus 4x plus 3. And I'm going to graph. Okay, and again, notice when visually you don't see any x-intercepts. So again, that's why we got the imaginary solutions. Okay, but again, notice visually when you're coming up the y-axis, you don't see anything till you hit this point right here, which is at a y value of positive 1. So my range goes from positive 1, and it is included, and it goes to positive infinity. In general, if your parabola opens upward, your range is going to go from the k value of the vertex to positive infinity. But that's only the case if it opens up. And then finally, the last question related to this particular problem asks you to find the axis of symmetry, which is another formula. The axis of symmetry is x equals the h coordinate of the vertex, because remember that visually the line of symmetry has to go through the origin. It has to go through, not the origin, but it has to go through the vertex. It has to go through the vertex. So visually you would have your axis of symmetry going through that vertex. So in this case it would be x equals 1. And guys, it's always x equals because it is a vertical line. Okay. All right. The next grouping of questions is numbers 8 through 14. And again, you're given a function, and the function that you're given is x squared minus 2x minus 3. And it's basically the same set of questions that we just walked through. And I can tell you there are 2 scenarios on the test where you basically have to do this. I give you a quadratic function and then ask you these questions. Okay, so again, for question number 8, as we begin looking at this set of questions, you have the function, and again, hopefully you recognize the function as being a quadratic because it has a high exponent of 2. And I've told you that the domain of a quadratic function is always and forever negative infinity to positive infinity. The direction of the opening, remember, is determined by A. A is the number in front of the squared term, and for this problem, it is a positive 1. Since it's positive, that means there's no reflection on the x-axis, which again means that the parabola is going to open up. Okay, so my parabola opens up. Visually, again, it would have that U shape. Okay, now as a side note, so you'll have the contrast and know the difference. Okay, remember that it opens down. Okay, this is just a little side note for you. It opens down if A is negative. Okay, so A could be something like -1, -2, negative 1/3. Okay, but that's how you know that it's going to open down. It opens down if the value of A is negative. Okay, so you'll hopefully have that information for the test. All right, question 10 asks you to find the y-intercept. Again, remember, to find the y-intercept of any function, we let x equal 0 and we solve for y. So if I substitute 0 into the function we're given, I would have 0 squared minus 2 times 0 minus 3. Now, I know some of you struggle with the calculations. If you do, guys, please take the time to go out and type it into your calculator. Okay, so we would have parentheses 0, close parentheses, square it, minus 2, parentheses, 0, parentheses, minus 3, enter. And I get a value of -3. Okay, so f at 0 here is going to be -3. And again, you're typically asked to express that as a ordered pair. So the ordered pair, which is always x comma y, would be 0, -3. Okay, so there is your y-intercept. All right, question 11 asks you for the vertex, and I'm going to write the function down again so we can view it and I can refer to it. Okay, so my function is f of x equals x squared minus 2x minus 3. And I'm asked to find the vertex. And the easiest way to find the vertex is to use the vertex formula. Okay, so remember, for the vertex, the ordered pair is typically h comma k. H corresponds to the x coordinate, which is the opposite of b over 2a. And then the k coordinate corresponds to the y value, and we find that by substituting x back into the problem. Yet again, A, B, and C. A is the number in front of the squared term, B is the number in front of the x, and C is the constant. So I'm going to have the opposite of -2 over 2 times 1. So I have 2 divided by 2, which is again 1. And I'm then going to take that value of 1 and substitute it into the original problem, so that I would have 1 squared minus 2 times 1 minus 3. And again, I don't want to make a calculation error, so I'm going to take the time to put it in the calculator. I would do parentheses 1, close parentheses, square, minus 2, parentheses 1, close parentheses, minus 3. And I should have a value of -4. Okay, so when I do the calculations here in my calculator, so I don't make a mistake, I get -4. So written as an ordered pair, the vertex is 1, -4. Question 12 asks me to find the zeros. Now again, remember that word zeros also can be written as solutions, factors, or x-intercepts. But to find the zeros, we let y, or f of x, equals 0, and we solve for x. And typically, to solve for x, we either factor or use quadratic formula. Again, I realize that most of you are most likely using quadratic formula, so that's what I'm going to use here. Okay, I could factor. I believe this one would factor, but I'll go ahead and do quadratic formula. Okay, so we would have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I would have positive 2 plus or minus the square root of 4 plus 12. Negative 4 times 1 is negative 4 times negative 3 is positive 12, all over 2. So I have 2 plus or minus the square root of 16 over 2. 16 happens to be a perfect square, so I'm going to have 2 plus or minus 4 all over 2. And then I have to consider both of those options. Okay, so I'm going to change colors here. Okay, so we would have 2 plus 4 over 2. So that's 6 over 2, which is 3. I would also have 2 minus 4 over 2, which is negative 2 over 2, or negative 1. So my zeros are ultimately 3, 0 and negative 1, 0. I have 2 of them. Remember, the highest degree identifies the number of zeros. And so since the highest degree of a quadratic is 2, I should have 2 zeros. Then we need to find the range. Again, think about your parabola. It's turned upward. My vertex is 1, was it negative 4? Yep, my vertex is 1, negative 4. Okay, and so my range, the first place I see it is when I hit that value of negative 4, and it keeps going upward. Now, again, as a side note, if it's turned downward, okay, if your parabola is turned downward, then your range goes from negative infinity up to the k value, okay? If your parabola is turned downward, the range, kind of the formula would be you go from negative infinity to the k value of the vertex. Okay, so again, that's a little side note, so you'll have it when you go to take the test. Okay, and then the last one for this question, or for this grouping of questions, ask you again, what is the axis of symmetry? Should be x equals the h coordinate of the vertex, because your axis of symmetry would go through the middle. Okay, so x equals 1, the axis of symmetry goes through the vertex. And again, guys, if you're struggling with this, use your resources, use the technology. So I could actually create for myself a picture. Again, I can go to y equals, and I would enter x squared minus 2x minus 3. And I'm going to graph. And there's my parabola. Okay, and I can at least get in the ballpark and tell what my vertex and my zeros are going to be if it comes down to having to try to guess. All right, the next grouping of questions, and I think there's two sets of these as well. Yes, there are. Okay, deals with polynomial functions. Okay, the next grouping of questions deals with polynomial functions. So it says, consider the following function. F of x equals x to the fourth plus 3x cubed minus 4x squared. And the first question says, what is the degree of the polynomial? Remember, the degree corresponds to the highest exponent, okay? So the degree, corresponds to the highest exponent. Now, I typically write these in descending order for you, but you remember sometimes website will trip you up and try to put it in a different order. So pay attention. Okay, so looking here, I have an exponent of 4, exponent of 3, exponent of 2. The highest one is 4. So my degree is 4. The leading coefficient is the number in front of the highest exponent. And if I'm looking at this again, my highest degree or highest exponent was 4. The coefficient or the number in front of that is an understood 1. So my leading coefficient would be positive 1. Really, those are definition questions, guys. The degree is always the highest exponent. The leading coefficient is the number in front of that highest exponent. Okay, then we're going to use those two pieces of information that we just collected to answer question 17. Because question 17 says, according to the leading coefficient test, how does the graph behave on the extremes? This is a question about the end behavior. If you go back and look at your notes, there were 4 different options. And you have to pay attention to whether the degree is even or odd. Okay, so you got to think, is my degree even or odd? For us, it was 4, so it's even. I know when it's even that both ends are going to do the same thing. So they're either both going to go up or they're both going to go down. I have to also consider that leading coefficient and whether it is positive or negative. And in this case, it is positive. So even and positive is going to look similar to a good old basic quadratic that is turned upward. And so my end behavior would be that it rises left and rises right. And again, I use that phrase, okay, that it rises left and rises right rather than the crazy as x goes to negative infinity, y goes to positive infinity, okay? So you'll see the words in the multiple choice part of the test on that question. All right, question 18 asks you how many zeros could the graph have, and it wants you to be very specific. Remember, the number of zeros corresponds to the degree. The number of zeros corresponds to the degree. So the degree for this particular example was 4, so I should have 4 zeros. Now remember, and this is not really a question that's on the test, the answer you would give me on the test is 4, but remember, some of those zeros could be real and you'll be able to see them on the graph. Others of them may be imaginary and you won't be able to see them on the graph. Okay, I'm going to need the function itself to do question 19. So let me go back up here and make sure I get the right function. X to the fourth plus 3x cubed minus 4x squared. Okay, so going back down to question 19, it wants me to find the y-intercept of the polynomial function. Guys, remember to find the y-intercept for any function, whether it's a polynomial, a quadratic, or linear. You let x equal 0 and you solve for y. So I would have f at 0 equals 0 to the fourth plus 3 times 0 cubed minus 4 times 0 squared. And again, I want to avoid making some calculation error, so I'm going out to my calculator and I'm going to type it in. Parentheses, 0, close parentheses, raised to the fourth power, arrow out of the exponent, plus 3, parentheses, 0, close them, raised to the third, arrow out of the exponent, minus 4, parentheses, 0, close them, squared, and I hit enter. And it is going to be 0. Now, I hope that would be obvious to you, but again, if you are struggling with the calculations, please take the time to use your calculator and don't make just a crazy calculation error. Written as an ordered pair, my y-intercept would be 0, 0 for this particular problem. All right, question 20 we actually looked at in class last Wednesday, but it asks you to find the zeros by factoring. So it kind of tells you that this particular polynomial can be factored. And guys, that's the only option you have. You cannot use quadratic formula or anything like that. You're going to have to factor. So I would have, remember to find the zeros, we let y equals 0 and we solve for x. So I have 0 equals x to the fourth plus 3x cubed minus 4x squared. The first step in any time that you are factoring to solve a problem, the first step is to look for the greatest common factor. And if I look at my problem, I realize, oh, all of those pieces have x squared in common. So I'm going to factor it out. X to the fourth, and I took 2 away. That leaves me with 2. Plus 3, x cubed, I had 3. I took 2 away. I'm left with 1. Minus 4x squared, so I got minus 4. I had 2. I took 2 away. I have none left. Then I have to realize, oh, okay, I now have this quadratic inside or a trinomial in the parentheses, and it can be broken down further. So I have the x squared that I factored out in common, and then I'm going to break the other one down, and I'm going to do it by trial and error. So I have x times x to get x squared. I need a pair that will multiply to 4 and subtract to 3. So that's 1 and 4. And I need a positive 4 and a minus 1 because I want to end up with a positive 3. I then know that one of those pieces, either x squared had to be 0, x minus 1 had to be 0, or x plus 4 had to be 0. And if I solve each of those respectively for x, I'm going to get my answers. I'm going to square root both sides to get rid of the square, realizing that it could be positive or negative. Add 1. So x equals 1. Subtract 4 from either side. So x equals negative 4. So written as ordered pairs, my zeros would be 0, 0, which actually occurs twice because you have, it could be plus 0, and then the second one would be minus 0. 1, 0, negative 4, 0. So technically I do have 4 zeros, and I should have 4 because my highest exponent, or my degree, was 4. It's just that one of them occurs 2 times, and again, visually you wouldn't be able to see that. Now, had you wanted to try to estimate those instead of doing the factoring, you might could get by with doing that. Again, you can go out and put it into the calculator. So you would have x raised to the 4th, get out of the exponent, plus 3x raised to the 3rd, arrow out, minus 4x squared, and graph. And you might be able to see that those cross. Again, remember, if you're having trouble reading the graph, you can use the zoom option. You press zoom and you zoom in. It's like the viewfinder on a camera. And then you choose enter. Okay, I'm not seeing it real good there. So then I might go back and maybe zoom out. So, but I can see, oh, it does look like it hits at 4. I do see it hitting at 0 and then 1. So again, you might be able to look at it on the graph, but again, it's probably quicker if you know how to do it by factoring. All right, then there's another one, another polynomial function. Try to give you a nice variety. Okay, so this one is f of x equals x to the 5th minus 3x to the 4th plus 2x squared plus 5x minus 4. And again, the first question here asks you, what is the degree of the polynomial? And again, so if I go back and glance, and I'm looking for the highest one, my degree here is 5. The degree is the highest exponent, and in this particular polynomial, that highest exponent is 5. So my degree is 5. The leading coefficient, or the number that is in front of that highest exponent, in this particular case, is again a positive 1. And so then I'm going to think about that. I have to think about the degree and whether it's even or odd. In this case, it's odd. Remember, when it's odd, the ends do opposite things. Ends do opposite things. My leading coefficient is either positive or negative. In this case, it's positive. And so when it's odd and positive, it looks kind of like my x cubed. So that is my clue that my end behaviors are going to be such that it falls on the left and rises on the right. Now, guys, there's no reason why you should miss that question, because if nothing else, take the function that you're given and plug it into the calculator, okay? And you can look with your eyeballs and tell whether or not what's happening on the ends, okay? Please don't make stupid mistakes. And I don't mean to be ugly, but it would be a stupid mistake. Okay, so we go out to y equals, oh, there's something going on with my calculator. Let's see if I can turn it off and turn it back on. I have to shut down. Okay, let me open it back up. Okay, but put it in the calculator if nothing else and use your eyeballs to decide, oh, it's going down on the left, which means it's falling. Or it's going up on the right, which means it's rising. Okay, there's no reason to miss that question. And hopefully this calculator will come back up in just a minute. While I'm waiting on it to come back up, let's see if we can maybe look at the next question. The next question says, how many zeros could the graph have? Again, remember the number of zeros corresponds to the degree. The degree was 5, so I have 5 zeros. Now, again, remember that's 5 total, and some of them could be visual on the graph or real, and others of them may be imaginary. All right, looks like my calculator's come back up, I think. Okay, so let's see if it's stuck in this mode for some reason. All right, it's stuck in that mode. Let me see if I can. Okay, I changed it to a different one, so hold on just a second. I switched to a different calculator. All right, so we'll go out to y equals, and I would enter x raised to the 5th, get out of the exponent, minus 3x raised to the 4th, plus 2x raised to the 2nd, minus, oh, excuse me, not minus, it's a plus. Whoops, and I didn't get out of the exponent. Okay, so let me see if I can back up here. Okay, I should have got out of the exponent right here. So I need to get out of the exponent. Ow. Okay, so 3x to the 4th plus 2x squared plus 5x minus 4. And I'm going to graph. And so again, hopefully you can see that it appears to be going down or falling on the left and rising on the right. Again, please don't miss that question just because you don't want to put it in the calculator. Okay? Ms. Ralston's trying to make it as easy for you as possible. All right, then 25 asks you to find the y-intercept. Well, guys, remember to find the y-intercept for any function, we let x equal 0 and we solve for y. So I would have 0 to the 5th minus 3 times 0 to the 4th plus 2 times 0 squared plus 5 times 0 minus 4. Again, please take the time to put it in the calculator, okay? So I would go 0 raised to the 5th, get out of the exponent, minus 3 parentheses 0 parentheses raised to the 4th, out of the exponent, plus 2 parentheses 0, close them, squared, plus 5 parentheses 0, close them, minus 4, and enter. And you should get a value of -4. Now again, I hope that one's reasonably obvious, but if not, guys, please don't make a mistake because you don't want to pull out the calculator. Written as an ordered pair, your y-intercept would be 0, -4. Now, question 26 is different on this question because honestly, guys, I don't have a clue how to factor x to the 5th minus 3x to the 4th plus 2x squared plus 5x minus 4. Now, there are other techniques where we could actually find the exact value of the zeros. But because of the 2-week class suspension, because of COVID-19, we don't have a chance to talk about that. So I'm having you estimate. Give me a ballpark. Between what two integers does the polynomial have zeros? And remember, we technically should have 5. That was one of the answers earlier. So if I go back to my graph, and again, I'm going to zoom in here so I can hopefully see it a little bit better. And it's thinking about it really hard. Okay. I can see here's 0, 0. And so I see that it crosses between 0 and positive 1. It crosses again between positive 1 and positive 2. And then it looks like it also crosses between positive 2 and positive 3. So I'm actually going to I can see 3 of them. So it appears that one of the zeros is between 0 and positive 1. I have one between positive 1 and 2. And I have a third one between 2 and positive 3. Now, I should have a total of 5, but I don't see but 3 on the graph. So that tells me, and it's not really part of the question, but that also tells me that I have 2 imaginary zeros that I can't see, okay, on the graph. And I believe on the test, Miss Ralston is nice enough to tell you that you should give me 3 answers here, okay? Even though you should have 5 zeros, you should have 3 that you can see. So I'm nice enough to tell you, oh, you need to give me 3 answers. If I ask for 3 answers, you need to mark 3 answers. If I ask for 2 answers, you should mark 2 answers. Again, don't miss it because you don't follow the instructions. All right, and then the last one, it looks like I got something kind of funky going on here with question 27. Okay, so I may have to come back to that one because it looks like my question has gone away for some reason. Let me skip down to question 28, and then I'll come back and look at question 27 because it's doing something funky. Oh, there it is. It reappeared. That's kind of crazy. But anyways, there it is. Okay, so let's look at 27. We want to do 2x to the 4th plus 7x minus 2 divided by x plus 3. Now, there's a couple of things to remember here, guys, that are super important. Remember that both your dividend and your divisor have to be in descending order of exponents with no missing terms. So when I look at that divisor of x, oh no, now what are we doing? It did this on me the other day, guys. Okay. I don't know what it's doing. All right. For some reason, it's hung up. I'm not smart enough to figure it out. So we will look at these 2 questions together first thing on Monday. That'll be a good little review for us with long division. Let me try again. Okay. Not sure what it's doing. Okay, I'm not sure what it's doing, so we'll look at those 2 first thing Monday morning and in class, and we'll go from there.